Well, thank you for having me here today and inviting me to give this talk. My presentation is UW Bothel's geodatabase project, mapping boundaries, hydrological features, and plant communities. I also would like to acknowledge that although I've listed here only the lead instructors in this project, 99% of the work has been done by undergraduate students, and you will see the names of them in different figures and tables throughout the presentation. So. Okay, so let's start. Yeah. So our campus houses one of the largest and most complex floodplain restoration projects in Washington State. If you're not familiar with our campus, this is how it looked our site in 1998, and this is 2013. So a lot of changes in between, but there has not been a formal or systematic way of analyzing the data, looking at changes systematically throughout time. And what we're trying to do is find ways where we can engage undergraduate students in the process of collecting data and analyzing data. Our project started in 2013 as an initiative from the Office of Research. And the idea was to develop some kind of dynamic environment where students and faculty can engage in applied biophysical research. So students build on their geotechnical skills, plant surveying skills, geophysical characterization skills to make this happen and to produce knowledge, geographic knowledge, spatial knowledge about our wetlands. So what are the challenges we have faced in the past 2 years? Well, basically you need some kind of high investment at the beginning to make all this happen, to create a systems infrastructure where we can work together on this. Finding common ground, especially where cross-disciplinary, interdisciplinary work is happening, is also hard to find. Information sharing is always challenging, especially when a lot of the data that we've been collecting has not been published before. So this is where we are now. We are currently building the initial layers to put in this geodatabase. We have completed vegetation community mapping of over 90% of the wetlands. You can see the different steps, different phases of our mapping process, and we've collected information. This is qualitative data on vegetation communities about our wetlands. So students have identified more than a dozen type of communities, vegetation communities, and we need to ground truth this and compare them with quantitative data that students are also collecting in the field. We're also completing a compilation and processing of historical data that came in different forms, analog forms, digital forms, georeference, not georeference. So we're trying to put all this information together systematically in a system. And this, surprisingly, this has not been done before. So we have a lot of data that has been just hanging there in the shelves of different people who started this process, the wetlands restoration process, in 1998. So we're collecting data on vegetation and hydrological features. This flow chart shows more or less the steps that we take to make this happen. So we do an on-site type of characterization first. Then students go there with GPS devices to collect information about the boundaries, location of where things are located in the wetlands, and then do differential correction of those points to generate point line polygon shape files, a little bit more accurate that we need for this database. So we are at this point. We've generated several layers of data in shapefile format. We're trying to go from this format and export this into a geodatabase structure so that we can organize the data more efficiently, more effectively, for analysis, spatial analysis, and also for sharing within our campus community, and probably later to the outside community as well. We are migrating the data that we've collected from a personal desktop environment to a server environment where we will be able to share map services, the data itself later. So for this purpose, we recently acquired a new server, a dedicated server for this particular project, and we've installed the software that is needed, specifically ArcGIS server, to put all this information there and make this transition more smoothly. So in conclusions, the geodatabase project so we're using this word as geodatabase more as a metaphor of integration synthesis. And it will serve as a catalyst of applied biophysical research in our wetlands at UW Bothell. The idea is that this project will facilitate research by providing opportunities for undergraduate students to get involved from the beginning in research and collaboration within this context of geographic information systems and science. And that's it. Thank you very much.